Hey everyone, this is 2011 question 3. This is a non-calculator question. It involves area and volume, which I believe you guys are very strong at. Okay, now if you're not, definitely do go back in the FRQ packets for area and volume and refresh. Okay, with a lot of practice, you guys could definitely get there. Okay, let's get straight to it. Here we go. Part A. We want to write an equation of a tangent line, okay, for the graph of f at x equals 1/2. So I always reiterate to you guys that when you make an equation of a tangent line, you need two things. You need a point and a slope, okay? So they give us the x-coordinate of our point in the problem here. It's 1/2. So we're missing our y-coordinate. Now our y-coordinate is actually in the picture. If you guys notice right over here, it's 1. So really the only thing we're missing is the slope. So if you guys remember, to find slope of a tangent line, we need to find the derivative, okay? So if you guys read carefully here, we're finding the equation of a line tangent to the graph of f. So it only makes sense to find the derivative of f here, okay? Don't find the derivative of g, because we're not trying to find a line that's tangent to g here. So if you take the derivative of f of x here, which is 8x cubed. The derivative is really just the power rule, 24x squared. We're going to evaluate that at x equals 1/2 to find the actual slope at that moment. So if you plug this in, you'll get 24 times 1/2 squared. And technically, you could leave it as equal if you wanted to. But I'm just going to keep on going for the sake of value, okay? This will be 24 times 1/4, which is just 6. So you have a point and a slope. You just have to set it up. Y minus y1, in this case it's 1, equals the slope, which is 6, times x minus x1, which is 1/2. Once you leave it in point slope, you guys, you can stop there. Equal is equal. Sometimes the scoring guidelines will bring this one over here, but it really is not necessary. Once you have it in point slope form, you just stop there. Equal is equal. You're all done. Okay? Part B. Finding the area of R. And R in this case, in the picture, is the region that's in between the two curves. Okay? So this is pretty much the integral of top minus bottom. The thing is, they don't really tell you what that top and that bottom function is, okay? So you guys have to have an understanding that we have a cubic function and a sine function. A sine function looks a lot more like that top one, just based on the way that sine functions look like, okay? So you do have to have an understanding of that. So that means that the bottom function is obviously 8x cubed. So here you would have to just integrate top minus bottom. So in this case, it's just g minus f. But since we don't have a calculator, we actually want to physically plug in our two functions here. Keep in mind that if you do have multiple terms in your equation, you definitely want to use parentheses in the case that you have to distribute a negative here, okay? Here, since we're doing top minus bottom, we want to integrate in terms of x, okay? So we're going from 0 to 1/2 because this is where our region starts and stops, okay? So sidebar, remember that the integral is sine pi x. There is a function inside of another function, but I taught you guys that you could use mental u substitution, which is just the derivative of the inside. The derivative of pi x is just pi, and if you take the reciprocal, which is 1 over pi, you can leave that on the outside, okay? Now all you have to do is just integrate sine. Remember that the integral of sine is negative cosine, and I put that negative on the outside so it looks like it's multiplying instead of subtracting, okay? And the inside just stays the same. That's how you quickly use u substitution without actually having to write out the u substitution, okay? The integral of x cubed is just x to the 4th over 4 and then you plug in that 8. All that's left to do now that you've integrated, notice how I don't have an integral symbol or a dx. We're just going to integrate this from 0 to 1/2. Okay, so all that's left to do is to really just plug it in. And I'm writing it out because you guys have to remember that when you plug it in, you're pretty much done. Notice how I didn't really simplify the 8 and the 4 here, okay? So that's top minus, I don't have a lot of room here, -1/pi, cosine of pi times 0 minus 8 times 0 to the 4th over 4. Once you have that set up, you could leave it. The scoring guideline will always go a little bit further, so just keep that in mind there. But equal is equal, so you guys could leave it there. That's an easy 4-point question. But yeah, definitely doable, okay? Part C, write but do not evaluate an integral expression for the volume of the solid generated when you're rotating about y equals 1. So you guys, first thing, you have to know what y equals 1 looks like. Y equals 1 is a horizontal line, so I would definitely illustrate that I'm rotating there. Notice how I already have a vertical rectangle. Let me erase that there. We purposely want a vertical rectangle because our equations are already in terms of x. Okay, we're trying to do as little as possible to not change our functions. Okay, since it's already in terms of x, we want to keep it there, so we want that vertical rectangle. So if you guys take a look at where it's rotating and your rectangle, notice that it's not parashell, but it's perpendicular, okay? But notice how that there's a gap here, so that implies that we're not going to use a disc, we're actually going to use a washer, okay? So a washer is pretty much pi on the outside, not 2 pi, okay, because that's for a shell. We're going to go from where the region starts and stops. But basically, we want our outside radius squared minus our inside radius squared. Okay? So the tough part here is knowing how to find our outside and inside. So if you guys remember, I had you guys illustrate this a lot. Your outside, you're going to start from where you rotate up until you're about to exit the region. That is my outside. Okay, right where you're about to enter the region is your inside. So we know a few things. We know that from the x-axis on up here, that little length right there is just our function f of x. That's 8x cubed, okay? But we want this orange dotted line that we have right here. So here's what we know. We know that from the x-axis all the way up to where we rotate, that is the exact distance of 1, according to our y-coordinate here, okay? So if we take 1 and we subtract out that f of x, we'll get exactly that orange dotted line. So here we go. It's going to be 1 minus 8x cubed, so that's our outside. Don't forget the square, minus, now same logic, this bold green line here is really just g of x, which is the sine of pi x. But to get just that tiny little orange dotted line up there, we have to take 1 minus the g of x, okay? If we subtract out the rest, we'll just get what's left, which is the orange dotted line, okay? Which is what we have here. Okay, if you guys read carefully, it says write but do not evaluate. Okay, oftentimes with a non-calculator question, they don't ask you to go any further, okay? So notice how they give you 1 point for the limits and the constant and 2 points for the integrand. So there's a lot of points to be earned here. Taking a look at this problem as a whole, you could definitely earn 9 out of 9 with practice, okay? This is definitely one of the easier FRQ problems to attempt. So practice well at it. If you get 9 points here or anything more than 4, that's extra points for potentially any other FRQs that you may not be so strong in. Okay? Thank you.